So welcome today to our session on multi-factor designs, kind of focusing on the split plot, uh, but we'll talk through the other multi-factor designs and give kind of a brief look at some of the other types of designs that are available in ARM. We'll utilize the trial map, that the tool to set up our randomization, set up the shape of our trial, and look at some of the options, frequent questions that we get when trying to get those going. So, as I said, kind of first up here are just kind of a brief introduction, definitions for the multi-factor designs in general. The idea here, as opposed to the regular RCB, the randomized complete block, that's kind of ARM's bread and butter that gets used probably most often. Multi-factor designs are really great when you're going to investigate two or more variables. The biggest thing that I think of is when you're trying to test the different combinations of these different things you care about, right? So that's kind of the key word, at least for me, when someone's starting to describe, their trial and what should I do. That word, different combinations, is kind of the trigger. So the advantage here is being able to look at the combinations of the factors, we call them, those variables that we care about. If we do every combination of the two lists of things we care about, then we can gain some advantages in our analysis. We have a little more power available to us. We can look at a few different things. We can look at the effects of each variable kind of just separately, look at a cross section of the one thing we care about, and then turn our attention to the cross section of the other thing we care about. And then also we can understand what the interaction may be when you have both of those present. So that's one of the big reasons why this would matter, why you'd use a design like that, is for some of those statistical outcomes. So the one key as far as just operation goes in ARM, as you're setting up your protocol, the big kind of gotcha is you would want to select one of these designs when you're in the middle of creating the protocol. So that first wizard, when you say new protocol, that's the best time to set the design to one of these multi-factor designs. And we'll see why. It just sets up the treatment interface. So the treatments editor, once you're in the protocol, will be just a little different for us when you're using one of these multi-factor designs. Pretty much everything else in ARM is the same. There's really not a whole lot else to see, other than, like I said, that treatment editor. The trial map will have just a little bit more information for us. And then at the way end, when we're doing analysis, there's a separate report, which probably won't go into the analysis side today, but we will look at those first two, just setting up a protocol in this type of design, and look at the trial map and what impacts that has. So I'm going to go to ARM just to point out that exact workflow here, really for any of the multi-factor designs. This is just kind of the one thing you want to notice. So in ARM, you use File, New Protocol. Of course, there's that blank sheet icon. Use that as well. We have our new protocol wizard. And in general, we've got your protocol settings. Most times you wouldn't have to do much here. If I hit create protocol, I will create a protocol file. I'll have all the different components, including the settings. So I can go back to the settings and change the information, and it's not really a big deal. Multi-factor, though, it is optimal here to go into your protocol settings. there's the button here, or in our new protocol checklist, there's also the study design that would maybe catch our eye. And by default, it's that RCB, but if I click on that, I can change it. And it opens up our protocol settings. So either way you get here, let's open up the protocol settings and choose a different design. So that's this big drop down here right underneath the design tab. And you can see we've got a pretty long list of different designs, and we'll go through a bunch of these today. But the key ones here at the moment are the multi-factor designs at the bottom, and there are 4 of them. And we'll go through them kind of one by one here, but that's kind of the key here is to go ahead and select one of those while we're in the new protocol setup. Then the next step there is to define your factors. So these are those variables that we care about. That was the different combinations of things that we're investigating. And in ARM, we'll call those factors. So there is a list associated with these that match up with your treatment types. There's also some other, so these would be your treatment types here down at the bottom, which might be pretty common to choose, but there are other things you might do as well up here. You definitely don't have to use this list, depending on the experiment and what you're looking at, but it can be handy as a standard terminology. The example, I guess if I start to fill things in, maybe let me go back to my design. In the end, I'm going to end up doing a split plot design. So maybe I'll just make sure that's selected before I start to fill it in. And the example today, there's all sorts of different things that could fit. I'm just going to do one of the usual types that we have in our tutorial files. And we'll say that I've got an herbicide study. I've got like 4 different products, 4 different herbicide products that I'm looking at. I'm wanting to compare, but I'm also interested in how those products perform with different tillage types. And so the key thought is every combination. I want to test each of those 4 products with every combination of a tillage type. And maybe I've got three different types, looking at how we want to cultivate with those products and understand how each of them does in each of those scenarios. So that would be our key here is A and B would be the herbicides and our tillage type. And I think I do have got tillage type right here, or if I wanted to use the treatment type defaults, cultural practice probably as well would work. I'll use tillage type because it's just a little more clear in this description. And then the levels is how many of that variable we care about. So like I said, I'm going to choose 3 different tillage types, and then my product will be, specifically, I might as well choose herbicide since that'll be the type of product that I'm testing. And we had 4 products of those. So in the end, what I'll end up with is 3 times 4, 12 different combinations. So I'll have a treatment list of 12 treatments because all 4 of these herbicide products, each one individually at the 3 different tillage types. So levels are the different types of that variable. For 4 different products for me, 3 different types, tillage methods, cultural practices, whatever term we use there is what we're doing here. Okay, before I get too far with this protocol, let's go back to my slides. Just want to run down some definitions of these different designs here. So the first one is the factorial RCB. Or you kind of rearrange that. It's really a randomized complete block design with a factorial arrangement of treatments. So we have kind of the classic blocking of each treatment appears once in a block. And then in this case, in my example, I've got 4 replicates. And then the difference from just an RCB, of course, is the treatments themselves are arranged with that factorial combination approach. So I guess here when I made the screenshot, I've got 8. So I really had a 2 times 4 instead of 3 times 4 that I'll be doing today. But the key is we're still blocking. If there's a gradient that we suspect in our trial site, stick to the tried and true RCB, try to capture that gradient in our blocking. On the other hand, if we still have that same factorial arrangement of our treatments, we still want to test all the combinations, but there really is no blocking that's needed. If we don't think that there's any gradient, if we're in a greenhouse, if we're in a lab where there is no need to create those blocks, we can make a CRD, a completely random design, just with the fact that the treatments are still arranged in that factorial combination. So that's the only key difference. You'll notice here, if I cherry pick treatment 8, that happens to be twice in this second row or range and doesn't appear at all in this first row. Doesn't really matter. It's completely random. There is no concern about a gradient or any difference from this row to this row. They're all trays on a table. Really no reason to think there'd be a big difference, so we don't care so much about their arrangement. You do get a little more power in that case, just strictly design, comparing RCB to completely random. If you don't have a gradient to capture, the CRD can give you some statistical benefits. So that would be the reason to use that factorial. But that's really the only restriction with those two. We're arranging the treatments. They have this combination aspect to them, but besides that, we can just randomize fully however we need. On the other hand, we have the split plot design. So that is a factorial. We still have the same general setup for the design, but the key difference with the split plot is there is some sort of constraint that we have in actually implementing and putting out the plots and randomizing things. So, most commonly with research done in ARM, it's because some factor really is more convenient or almost has to be applied to a larger area than just a single plot. So examples would be maybe a variety. If we're testing different varieties, I can't, the equipment is just too large that I can't just plant a different variety, one in each plot, and totally completely random like we saw in the previous. I need some sort of pattern. I need to be able to drive the tractor down a range or a row, and then everything obviously is going to be that same variety. And then maybe my product that comes in, of course, I can spray by hand with much more flexibility. So one of the two factors is kind of really forced into a pattern. The timing is another good one. If I have to do planting or treatment application at different times. Obviously very hard to pick and pop with that as well. So having everything grouped is when the split plot comes into play. So we're just having to limit our randomization a little bit. But if we at least do it systematically, we can adjust the analysis appropriately based on that pattern, that constraint we had to do. So the factor A is grouped together. So back when I'm in my ARM, how do I know which one of these should be first? My main unit in a split plot, that factor A, also called the main unit, that's the one that has the constraint on it. So tillage typing, and that's the one that I have troubles implementing. I can't just totally randomize wherever I have that constraint. So that's your factor A, and those will get grouped together. So here in my picture, you'll notice I've got that plot number and treatment number, but now there's a couple more numbers. And it's talking about, so like A2 is our factor A. So we're talking about the tillage type, the second level, the second tillage type that we're going to perform. Notice that those two are right next to each other. And then our different products can be random within that. So the product factor B, that's also called the subunit, that can be randomized however. So as you imagine these pairings of colors, you'll notice B1, B2, they can be B2, B1. So those are random within. Of course, again, I've only used two, so there's not a whole lot of different combinations you can run yourself into, but that's what the split plot is. We have this constraint we got to work around. And then finally, the last one in this list is the strip block, or also known as crisscross. And we're kind of building on that split plot idea. This is a special type of split plot where we need even more separation than just what we had saw there in the previous screen. Now we're going to lay out those main units perpendicular within the replicate. So you're almost doing both levels. Not only do we have to, within a replicate within a block, do we have to kind of group things together, but now those groups need to be more separate as well. So I've boxed in one replicate to just kind of visualize. If I go back one moment, we did have those very same plots we had to have grouped into our A's, our main units. Now we say, well, in addition to that grouping, I actually can't even have them side by side. They have to be perpendicular even to that. And so now we get this really tall, really narrow trial map. But again, just depending on what you're studying, what the constraints are in the real life implementing of this, you may have to use these designs. But instead of just doing, kind of hand cooking a randomization to meet those constraints, and then just that's it, we have these specific designs, both in part to help us set up the map to look the way we need it to, but then also this is important in the analysis. By getting the design to match truly what we're implementing, then the statistics done in ARM later on with your data will be smart enough to understand what you had to do to make it work. And we can then adjust the statistics accordingly to do the right thing. We're not making assumptions about just how random things are laid out that aren't even true. So it's kind of a dual purpose as we look at setting up the map here. Just the practical, lay this thing out, document it correctly, but also the analysis is really important to get that right, at least, right? Okay, so back to ARM just to tie the bow on our design here. So today we'll talk through that split plot because as we saw, just a general factorial is just an easier version of the split plot, right? I just don't have any limitations on me. And I think the split plot certainly more common than the crisscross. At least just in colloquially speaking on the support questions I get, at least the split plot seems more common. There was a question here about changing the plot numbers. And yeah, we definitely can do that. I'll show that here since I've actually got the settings opened up. Um, Looking at the specific numbering we'd want, where the collaborator kind of wants the split plot labeled as plot 101, and then you have two. Let me go to my slide. Maybe really this would be like plot 101, right? The one main unit they would think of as 101, and then you kind of have 101.1 and 101.2, left half, right half. Um, I don't think we have the ability to number those like that automatically. Um, Here on the layout tab of the settings, this is where you could control the numbering and the different systems that we have. But to ARM, a plot is not the main unit. It is each individual experimental unit. So I don't think we have a way to automatically do that. There is, once you're in a trial, there is a section for alternative plot numbers. So if you wanted to hand type in, or you could go out to Excel and copy and paste back in that type of numbering, ARM can accept your own, your own unique numbering, and it just kind of creates a mask over the top. So I'll try to remember if we've got time and we get into a trial, I can show you where that spot is. But short answer is no, we can't quite do 101.1 and 101.2 because each experimental unit is its own plot. And we'll come back here to this layout here. We'll see that once we do the trial map too and look at some other other options there. Okay, so here I am. I'm in the new protocol workflow. We came in here because we wanted to make sure that multi-factor design is set up. And I've chosen my factor levels, my factors, and my levels, how many of each. So now when I proceed through here, I'm going to go ahead and create my protocol. And the only difference, really the only reason we wanted to do that right here in the settings is because now if I go to the treatments editor, we'll see it does look a little bit different. We have sections within our treatment list. So this is really probably about the only thing you would see visually just offhand in a multi-factor design. And this will only be in the protocol actually as well. So instead of listing out the 12 combinations of our tillage and our herbicide, instead we just give ARM the list. So I'm going to create the list of the three different cultural practices I'm going to do. I'm going to fill in the 4 different herbicide products that I care about. And that's it. Then ARM will, when we create the trial, it's going to create those combinations for us. I've got kind of a slide to try to visualize that. So here's where we're going. I should have filled those in first, but anyway, we're going to take that list of each one of these tillage methods. I'm very creative here in my example, and pair that with each different herbicide product. So treatment one, when it's all said and done in the trial, treatment one is going to be the combination of our first tillage method and our first herbicide. And that also is described here with that factor ID and the level number, A1, B1. It's kind of what you end up with, almost coordinates, the combinations of each thing. Then we'll stick with that A1 and let's pair it with the second herbicide. So that's B2. And then with B3 and with B4. So you have all four of those. Then we do the same thing with tillage method 2. Pair that with our first product, pair it with the second, with the third, with the fourth, and so on. So that's what happens when we take our protocol and go to a trial. This slide is showing us that actually now we do have a way to see that multiplied out list even in a protocol. So under the Tools menu, you can multiply out treatments, and then that'll actually create that list. Oops. Let's watch this video. Actually, I forgot. I've got this one here just to show one of the reasons to do this. Actually, let me pause it here. It's not strictly necessary to see that list. It's helpful to visualize. I'll probably do it here before we create the trial just to see what's going to happen. But there are a couple of times, a couple of cases where it actually might be necessary to get that list correct in the protocol. So this example, maybe if I've got 3 different products that I'm testing at 3 different rates. I have a low and a medium and a high rate for each one of them. Well, if each one of these products have a different base rate, so the low is just the 1x that rate, but then the medium is 1.5 times that, and then the high rate would double this base rate of the product. Well, I can't fill in the rate in kind of the regular method because depending on which level of factor B I have, the number is different, right? I have a different multiplier. So in this case, I can't fully describe and get the product rates correct by just giving this list in the protocol. So I need to use that multiply out treatments. And I think this will show us once we run that multiply treatment, then I'll see this full list and it'll still be in my protocol. So that way, if I'm just a sponsor going to send this out to my different trial lists, I can make sure to get the correct rate information in my protocol before it goes out. So that way I'm not relying on the trial list to understand all of this and get it all right, especially something like our application rates for our products. Really want to make sure it's clear and obvious to them. So now I get 3 times 3, there's 9 different products, but again, at the initial step here, I don't have the right numbers. Right, so I've got my Accord product. The first 3 are the low, the medium, and the high. So I've got my base rate of 2 pounds per acre, but I need to adjust this number 2 for that second to multiply by 1.5. And then I need to double it for that third. So if I create that multiplied out list, now I can go in and edit. And I think there we go. It'll refresh here. Now I can make changes to this list to put the right value in. I don't need all that extra information. I'm just going to do that multiplication and get the proper rate for each one of those. So that way, when I send this out, there is 0 confusion on the trial list level. They can just come in and apply Canon at 3 pounds, apply Brominal at 4.5. It's very clear. It's still a factorial, we've still, matched that combination. We were just able to clean things up and make it very clear for the trialists. So that's the reason for this function in the protocol. Let's go back here to ARM, and just so we can kind of continue through the list, I'll just type in real quick. Again, I'll be just as exciting as my example. Won't even get too excited. Oops, that's supposed to be method number 3. And we'll just call it product 1, product 2, and product 3. And product 4. Again, as this being the treatment editor, of course, I'd fill in actually more information about the products, since these are treated products. Sometimes, like in this case up here, this might be all I really would need is just the name of the level. If it's not something that's some formulated product that's being applied, just using the treatment name as the descriptor of what this is. If it's the timing, for example, this is 7 days before, or whatever the timing levels are, just using the treatment name, even though it's not a treatment, we're just thinking of it as the name of the level of the category that we're testing. Finally, the last section here is the comparison treatments. Not sure how common these are. The idea just would be if you have like a standard product that you're wanting to compare against. I'm interested in this whole combination here, and I just have a standard I want to have present at the trial to compare against. Something that's not, it's really any treatment that any plot that you want present there in the replicate design, but it's not part of the factorial arrangement. We won't be able to run any statistics, any of the factorial statistics on these treatments, but sometimes it's just used good, as a good reference, or maybe in some calculations or something. So that's where if you did have that comparison treatment, you would put it here. Maybe for me, it's going to be the check. Probably in all likelihood, actually, a check treatment you would almost want, depending on how many checks would you want in a replicate, right? If I want a check that exists on each tillage method, so that way I get a good baseline on each of those types of tillage, that might be important. So maybe I should have that as part of my design. That would be part of the factorial here. And there's really no problem with having the check, maybe I'll call it the untreated here, in this list. The key difference now is I'll have 5 times 3, 15 total treatments, 15 plots in every replicate, because I want that check really 3 different times in a replicate, 1 for each of the tillage types that we're doing. Alternatively, if I just need the 1 check plot in each replicate, that's really all I need, then we would leave it out here in the comparison treatment. So that's the key difference on something like the check or anything else as you're trying to decide where would it belong in this list. Not sure how common this is. Like I said, I am going to include it in today's example just so we can see what happens with it, as a comparison for us. Okay, that's going to do it for the protocol side, really, setting things up. Said there's no difference. The site description is all the exact same. The only difference your study design is the split plot. The assessment section is also identical, where we can plan out our assessments. Nothing is functionally different, really, anywhere else besides that treatment list. So I'm going to go ahead and create a trial. And it's unhappy with my choice of treatment type. Let me just clear those values out. They really don't need to be there anyway, because I just have my treatment name is really all that's required. So there we go. And of course, I'm shortcutting most of the important things in the protocol, like getting your trial IDs planned, fleshing out your assessments. We're just kind of focused here on our treatments. So here now I have my trial map. So this is the randomization portion. And the key here, we have the color by here on our properties panel. We see that pattern, right? So I'm coloring by factor A to show, because we chose that split plot, we have within each replicate, so we have 13 plots in a replicate, we have the treatments have to be grouped. So all of the treatments that are A2s are together in space here, then the A3s, and then the A1s. As luck would have it, so each of those designations, whether A2, then A3, A1, here we have A2, A1, A3, that designation is random. We got kind of lucky here. We just about ended up, we have a complete straight shot here of all the A2s happen to be first within each replicate, but it doesn't have to be that way. And if I were to hit re-randomize to just get a new randomization, I'm sure we won't get nearly as lucky. There's a little bit more of a difference. Strangely, not all that much though. We still had 3 replicates that lined up the same, but that's the main plot there. We still can color by just straight treatment number. Want to get a sense of how spread out things are, but of course there's a pattern that 5, 6, 7, 8 is the group of A2s, and it's kind of inescapable that those are near each other. One extra thing we can do, so in general, with the trial map, if we already have a randomization that we have decided on, we can dictate that to ARM using the trial map. There is a drag and drop mode. So if I turn on this auto select for move, I can move the treatment designation however I want. So maybe plot 101 is treatment number 5. I can just drag plot 101 and it grabs just that treatment because I'm I'm moving just the treatment assignment. I can move and switch 7 and 5 around. So that way treatment 5 is at plot 101. And I can make this map match what I've already decided. Maybe I have some other tool that decides their randomization or whatever. I can make that match. Special to a split plot, we have a drag and drop option for the main unit. So now if I click on plot 101, the selection that happens is actually that 4-pack of plots. So I can control, like we had said, the designation of A2 is first. Well, maybe A2, that whole group should be in the middle based on how I've chosen to randomize. You can drag and drop that whole main unit around. And you just drop it on a plot and it'll switch those 2 items around. just a quick note, that's treatment 13. It's not colored. It doesn't have the A's or the B's. That's our comparison treatment. So it's not part of the design at all as far as the factorial arrangement of treatments. So it's just hanging out at the end of each replicate. We can still move it if we needed to move the entire plot. You'd probably have to make room. Maybe I'd insert a column here so that way there's room for some of these to move. So maybe I don't want them all in one straight shot. So I would do something like that. Whatever it takes. And maybe that's kind of one of the reasons those comparison treatments aren't used often. Kind of ruins the math of how nice things might fit in neatly, having these oddball ones floating around. All right, let me re-randomize once more. We can just get back to the regular size here. One couple of options that we can do to kind of help set things up the way we might want in the trial map. We can go into the settings. We'll go back to that layout section here this time. Controls a lot of what that map will look like. So a couple of things to point out. We talked about the numbering system a little bit, and we can control where the numbers start at. There is a treatment adjacency. Doesn't fit a whole lot here with the split plot since we're already kind of limited where different treatments go, but it just tries to limit the straight shots that could happen where you'd have across two different replicates the same treatment kind of bordering itself. So by putting one here, there's one plot that has to be separate from that same treatment across replicates. The block size is nice for controlling the overall shape of your replicate and thus the whole shape of the map. So in my case, we have 12 different plots here. So maybe if I needed it to extend really into two different rows, so I can't quite go quite as wide as that 12, I guess 13 plots in total with that comparison treatment. I have to break that up into two rows. Maybe I'll set the block size as 7. Now with the split plot, I am limited. I kind of forgot about that. So we're in trouble here with the split plot. And that 13 is causing us grief. I think I might just cancel the trial creation here and get rid of that comparison treatment. Just throws our math off what we might care to do. So let's randomize one more time. My headset's starting to beep at me that I might lose my battery. So if I cut off, that's why, and I'll switch to a new headset. So we'll see if we can make it to the end. So we've got 12 here. In a normal RCB, it's going to let us do whatever block size we would want. And my example was 6. We are limited though, because that would not allow us to keep our groupings together. So maybe a block size of 4 could be useful. So if I select 4, being a multiple of that main unit size, now we can actually do that. So if I color by replicate, just to help visualize what we have, now that replicate that would be 12 plots wide, now is just 4 plots wide, and we have 3 blocks within that rep. So that's one way to kind of change the shape of your map. We're still sticking with our multi-factor design, things are grouped, but now I could rearrange, and maybe I want to rearrange my replicates. So if I auto-select the second replicate, I can drag and drop this replicate next to replicate number 1. So I'm just going to take plot 401 and drop it in the empty space to the right of that first replicate. ARM kind of creates some columns for me to be able to arrange that accordingly. So now I have slightly different size of a map fit the way maybe the space I have in my field, and yet we're still abiding by that factorial design. So that's the block size, and that's valuable in really any trial, getting the restriction on how wide your row is. If you're in an RCB, this number can be literally anything. It really does not matter. If you had those 12 treatments and you wanted a block size of 7, even though it doesn't really divide nicely, it doesn't matter. You can do that. The only reason we were limited was because of our split plot design. Having to have those grouped together creates a limit as to what size of block we can have because we can't arrange things nicely. One more thing, let me get rid of the block size depending on your limitation. So we've been talking about kind of within a replicate having to group depending on what you're doing, and maybe tillage, especially even just trying to do this one main plot isn't enough, but I kind of really need this whole swath, the entire slot number 1, if you will, from each replicate needs to be the same tillage type. You can do that, of course, by hand. We could use the auto select remove and just drag and drop the main units just to make them line up, right? Certainly I could do that. One could argue that's less random because I didn't let the software just generate it for me. So what I could do, let me re-randomize first so it's clear that we didn't start with that already. What I could do is in settings, there's an option at the very bottom specific to a split plot design where we can have one of the units not randomized. So in other words, the A1 will always be the first set within a replicate, then A2 and then A3. So the main units won't be random within the replicate. And if I do that, we'll have the nice pattern like we talked about, kind of locked and guaranteed. We still are random within that B. So within our main unit, the B's will vary. So there is still randomization here, just trying to get as much random that we can based on all the constraints that we have overall. So that's really that's the split plot, kind of the messiness that can come with a split plot design. There was a question here talking about the treatment list, how that would appear in a Word doc. So yeah, if you want, print out your protocol, use the print reports to make a nice document of the protocol. This will the list. Let's just do that actually. I'll cancel this and go back to the protocol quick. So in print reports, of course, we can do the protocol treatments. And what I can do, that's very small. I wanted to make sure it was doing that. There's an option here in the protocol treatments report specific for multi-factor designs. And so you can choose how the treatment list will display. I can have factors and levels, or the treatment list, or both. So I'm going to have both on because then I can show you what each one of them is. And I'll zoom in here a little nicer. So I've got the protocol treatments page, two different pages. So the first option, the first page matches the first option where it shows the factor and the levels. So really kind of just the way we have it on the screen here. Now, right now, this looks pretty weak, right? I didn't spend any time, I didn't put any effort into actually describing these products. So it's very, very useless, but that's only because I'm going fast and I'm not being very descriptive in what I'm actually doing because I'm not actually doing this research. But you would have real details here, right? It actually described the tillage method itself. Maybe there's some fields here that would apply. Maybe the timing, perhaps. There might not be much with the tillage. But for sure, those herbicide products, I should fill in the formulation details, the rate, the applications. It would all be fleshed out like you would see in a regular protocol. And all of that would then be listed here for each one of the products. Then the other view would be the multiplied out view. So that can be looked at just on the report. If you like that multiplied out list, just like it would show up in a trial, all 12 of them here with all those details, you can get that with the treatments option on the protocol treatments report. So hopefully that gives you kind of the view here. Did this give us, it did, I guess it didn't list the levels, did it? Reading your question one more time, the factors themselves not being identified, we aren't saying A1 and the B1, A1, B2, those different combinations, those aren't listed here. So I guess it is not showing that quite as fully. I think it will in the trial. Let's see real quick if we try the multiply out. It's going to save it. Let me just throw it to my desktop here real quick. So once we do the multiply out, we do see the factor ID and the level number. Let's find out if that changes then the report at all or not. I'm guessing it maybe doesn't. No, it doesn't. Okay, that's a good item of feedback. I'll jot that down as just maybe a possible enhancement for the treatments, protocol treatments report, right? That would be the protocol treatments report. Can we see the factor and level details on the report? Thanks for pointing that out. I have never noticed. We're kind of missing that part of it. Okay, we're almost out of time. Let me go real quickly back to our presentation here. Did have a couple of other designs that are available in that list as you're setting it up. I'm definitely not an expert on many of these, but just wanted to give a real quick look at the different types. Just so you know, they're available in ARM. ARM has all of the knowledge to set up the map according to each of these designs. And then, like we had said, that it also ties in with the statistics too. The ANOVA knows what we've done with the randomization and can be smarter than in the statistics for with those rules. So first one here is the Latin square. So this is a limitation, again, not a factorial design at all, just looking at your list of treatments. Each treatment can appear only once, both in a row which usually would be your replicate, but then it also can only appear once in each column. So if your trial location has a two-way gradient that you're aware of, this is really good for that, because now we can capture both of those, kind of block for both of those gradients that might be present. So it's kind of like the Sudoku puzzle, if you've ever played that. Same idea with the Latin square. That treatment can only be once in each column and each row. The limitation here is however many treatments you're testing, that has to be how many replicates you have. Otherwise, there's not enough space to have one row and one in each column. So you end up with a limitation as to what size of experiment you can do. Lattice designs. This is considered an incomplete block design. Basically, in addition to the replicates that we're setting up, that's grouping the treatments in a replicate. Within that replicate, we create another grouping to try to really increase our efficiency in the analysis, so that we don't need every combination necessarily to still understand and get some results. So the hope is we don't have to do as many replicates, less area we're using up, but we still are controlling for that variation that we just can't get away from in our field or wherever we're doing the study. There's different kinds of different systems for formulating these groups. The example here I have to the right, we're colored by replicate, and we're then really just looking at the grouping of the three. And then I have 4 groups of 3. And it's just keeping tabs on how those groups work together. And so there's rectangles, there's alpha lattices. You put in, once you choose the lattice, there's kind of a wizard that'll kind of help you into what combination would work based on how many treatments you have. So a bunch of different kinds of lattices. You'll notice in that list, all these different types. They're all tied back to the idea of a lattice design. That's about all I know. I don't know the details kind of on each of those groups, but we do have that capability. And then finally, last design, as we're filling up our time, augmented designs. These are when you don't have enough material to maybe replicate your test treatments, but you have plenty of control material. So you actually replicate how many checks you have in the field, and then you just kind of have one for each test treatment in each replicate. So this is usually the request comes from variety experiments, maybe very early on when you don't have that much of the product. Let's throw a lot of checks out there and just put what we can in the field, and then the analysis can try to help understand based on just having a lot of data on those checks. Even though we have less data on the treatments, we can craft our analysis accordingly. So those are the augmented, and there's a randomized complete block and a CRD version of that augmented setup. Okay, a little fast and furious at the end there with the designs. Most of those kind of are pretty involved. So hopefully you kind of know what you're doing already if you're using those designs. But certainly if you're trying to implement them, you want to see it a little slower, get in contact with us. We can kind of help walk you through those other designs too. Same thing for the split plot. That's kind of the most common question this time of year, especially. How do I get my split plot set up? Or if I'm trying to implement it in the field and trying to get ARM to match, just get a hold of us and we kind of help get ARM to set up the way you're trying to set up your trial. All right, so that's time. Thanks everyone for joining us today, and hopefully we'll see you again at a future webinar.